Hi, in this video we'll demonstrate a couple of more examples that are slightly different than the ones we did last time. In this situation, I'm integrating x squared minus 3x plus 2 over x plus 1. And now notice in the last example, the degree of my numerator was smaller than the degree of my denominator. And now my degree of my denominator is smaller than the degree of my numerator. So that's probably going to be a good indication that you're going to need to apply this next concept that I'll show you. Okay, so if we look at our denominator, remember we were integrating 1 over x. I still have something that kind of looks like 1 over x, and the derivative of x is just, or of x plus 1 is just 1. And I have that certainly, but now I have this big thing in the numerator as well. So there's really not a lot I can do in that respect unless I simplify this. And the way I'm going to simplify it is by simply dividing my numerator by my denominator. Okay, and remember long division. Okay, I can hear you screaming from here, but that's how we need to do this. We need to divide x squared minus 3x plus 2 by x plus 1. So remember, when we do long division, we ask ourselves what times x gives me my first term here, x squared. So x times x gives me x squared. And now to fill in my numbers down here, I take x times x gives me x squared. X times 1 just simply gives me a positive x. Sorry about that. And now remember too that when we do long division, we are actually subtracting. So our signs on here change, right? I get x squared minus x squared, that goes away. And I get a negative 3x minus an x, which gives me a minus 4x. And then my next step is to bring down my next term, which in this case is a positive 2. And then I start the process all over again. What times x gives me a minus 4x? Well, that would be a minus 4. Minus 4 times x gives me a minus 4x. And then minus 4 times 1 gives me a minus 4. Again, the number one mistake students make is they forget that in this process we are actually subtracting. Okay? So we get minus 4x plus 4x, and then 2 plus 4, because we're minus and a minus. So my remainder in this case is 6. Recall that when we have a remainder, we can rewrite this as plus 6, and then we can stick our remainder on top of this number, which is x plus 1. So now, in reality, I can rewrite my integral as x minus 4 plus 6 over x plus 1. And now, if you notice, this is not very hard to integrate at all. Remember, when we are doing sums and subtractions, we can just integrate the pieces. Okay? I keep forgetting my dx's. Sorry. All right. All right, so the integral of x just becomes x squared minus 2. The integral of 4 just becomes negative 4, just becomes minus 4x. And now we're applying our logarithms here. The integral of 1 over x, or in this case 1 over x plus 1, with the 6 on top, would just be 6 natural log x plus 1. And then I need to add my constant. Okay? So the trick here is when our numerator typically is greater than the degree of our denominator, then we're probably going to apply subtraction. And I have another example here to show you it again. So I'm going to take x minus 3 into x cubed minus 3x squared. Notice I'm missing an x term, so I'm just going to put that in as a filler, a 0, plus 5. All right, and again, we start the process all over again. What times x gives me x cubed? That's going to be x squared. And now I multiply x squared times x cubed, x squared times negative 3 minus 3x squared. And now remember, I can't emphasize this enough, you're subtracting, so the signs on these change. X cubed minus x cubed goes to 0. Minus 3x squared minus a minus, or in other words, plus 3x squared, that also goes to 0. And now I don't need this term at all, right? Because 0 times 0 is going to give me 0, okay? But my remainder would be 5. So again, I can rewrite this as x squared plus, take your remainder, stick it on top of what you're dividing by, x minus 3. So I can rewrite this integral as the integral of x squared plus 5 over x minus 3 dx. Okay, and here again I can just integrate it in each piece. Okay, the integral of x squared is just going to give me x cubed over 3. Here my derivative is 1, I have that, so the integral of 1 over x, again, I'm going to bring my 5 here, it's just going to be the natural log of the absolute value, x minus 3, and then add my constant. So I hope this helps. Again, this is not always the case, but typically if our numerator degree, in other words, the highest term on our x, is greater than the degree of our denominator, we'll need to do long division before we try to integrate.